All right, we'll get going. It's 5 after. Welcome to session 8. This week we're going to talk about SMD soldering. And this is to prepare us all for our upcoming in-person build day, which will be this Saturday, where we're going to be putting together our um, bandpass filters. Now, some of the stuff I'm going to show you, they're suggested items in that. So let's sit over here to the presentation real quick. So our goals for this session, if I get it to hit play, is we're going to basically go over the tools needed for SMD work. And I'm going to demonstrate how to use a soldering iron to solder SMD components, and then I'm going to show how to use a reflow plate, which is much easier. And it's what I use whenever I'm actually using a stencil. Let me see if I can find a picture of a stencil here.
While you're looking, can you hear me?
Yes.
Radar shows we're probably going to get hit at 9 p.m. with thunderstorms.
Oh, great.
Anyway, they're not always right. I'm out.
Well,
No,
okay,
I'm off verbally.
oh, okay. So I just wanted to give you an idea what a stencil looks like. So what it is it's basically a piece of stainless steel, real thin, um, just a couple of mils thick, that actually have cutouts for all the solder pads. And what you do is you'll put solder paste on it, and you'll spread it across it so it's evenly distributed. And then when you take that off, then you can put your components on it, and then you can actually set it on a reflow plate. Or put it in a reflow oven, and as it brings the temperature up, then the solder will melt and actually solder all the components to the board in one go. So this is the preferred method when instead of doing it by hand. And that's what we're going to actually use this weekend. Is I've got a stencil that'll be coming to where we can lay down the solder paste for all of our capacitors, and then we'll take it over the reflow plate and solder it. And then when we're done with that, then we'll wrap our toroids and solder those and the end connectors in using through-hole process. So I wanted to kind of go over some of the tools that if you're going to do SMD soldering, some of the things that you're going to need. And first of all is having a good soldering station that can at least get up to about 350 degrees Celsius, or around the 600 to 700 degree range, 650 to 700 degree range. And there are a lot of kits that will come with the soldering iron, as well as a hot air reflow rework station like this one. And normally you use the hot air station to actually remove components, but you can also use it to solder components by laying down your stuff and then hitting it with the air and holding your chip in place, or your capacitor or resistor in place, until it actually the solder melts and forms your bond to the copper. The other thing you're going to want to look at is, if you're going to do soldering by hand and also doing rework, you're going to want to look at a soldering microscope. And this is going to allow you to get up close, see what's actually going on as you're soldering or desoldering something. It's also great for inspection to make sure you don't have any bridged pins. And you'll probably see me bridge a couple of pins tonight when I solder on some of these chips. And we'll use that to inspect it and then clean it up. Another thing you're going to want to have is a good set of electrostatic discharge safe tweezers, because you're going to basically need to hold your components with the tweezers while you're soldering them in place or while you're placing them on the board, and you want to make sure that they are that they won't pick up an electrostatic charge, because you can ruin some of the chips from electrostatic discharge. This is just a simple set. You can actually just get one or two, or you can get them in sets. And another is going to be a good assortment of soldering tips. Some people like to use a flat blade tip or a wedge type tip. I prefer using a pencil tip. But you'll find that some of them work better for you. I think some of the examples that that I put in the resources of, they're using kind of one of these blunt tips, like you see, like the third from on the top, for doing to do your stuff. I kind of use like the second one there and the second one on the bottom. You're also going to want to get some solder. For normal, I suggest like a 60-40 tin lead. You know, that works all around for even doing your SMD work, if you're doing it with a soldering iron, or if you're doing through hole work. If you're going to be doing stuff with a hot plate, you're going to want to look for some low temperature soldering paste. And this stuff here actually has a melting point of about 138 degrees Celsius. So it will actually melt and form at a much lower temperature compared to running at 300 degrees. And we'll actually be using some of that tonight. And you're going to want some Rosin Flux. This is good for cleaning up the board, as well as cleaning up your solder paste in that after you solder. And you'll see me using it tonight to kind of dilute the solder paste, so that we can kind of make a solder slurry to do the chips. Now, you normally use this for cleanup, and you won't use it with a stencil, but you will use it if you're trying to clean up, if you're doing things by hand. And then this is an example of an electronic reflow plate. What it really is just a hot plate that you can control the temperature at. And it gives you, the top is the current temperature, and the bottom is the set temperature. And then what you do is you normally just lay your board down on it, and you monitor it until all the solder paste melts, and then you move it off the side and let it slowly cool down. And you'll see an example of that today. I've actually got one set up directly underneath on my overhead view here. So that's the top of the solder plate. Okay. Now you can get fancy, and you can get a reflow oven, which maybe Dale will be bringing his. I have one that I'm in the process of modding to get a much more stable temperature curve. Apparently the cheap Chinese ones, they leave out some of the controls, and they don't do as good. So there's tons and tons of mods that you can do on a $200 reflow oven to make it worth like a $500 reflow oven. All right, so we're going to start out, and I'm going to skip over here to my microscope. And this is a practice board that I bought. And this is great for just doing, just for practicing SMD soldering. There's a chip for a place for a 555 timer. And then there's another chip here. There's diodes in here and resistors. And this actually has at the top, it basically has 4 different sizes. So you've got 1206, which is what we're going to be working with. You've got 0805. You get over here on the other side, you've got 0603s and 0402. So they get really, really small. And really that depends on how much space you're trying to save is how small you'll go. I tend to like to use 1206s. You can actually get some that are a little bit bigger, but they're harder to find parts. And I'll kind of show you some of the different. So this is what a 1206 resistor looks like. And then let me bring in another one here. I think this is an 0805. You can see that it's a bit smaller. And then we get down here. I think this one here is an 805. Let's see. Yeah, here's a 0603. You push that in. See, it gets even smaller. And then you get down to the smallest size here. That's an 0402. So you can see why I like to work with the bigger ones. They're a little bit easier to deal with. Now, let me show you some examples here. Here's an example of a LED. And that's about I'd say that's about an 805 size. And then we've got some transistors here. You can see well here, I guess, let me pull back the plastic. And you can see it a little bit better. Open the package here. Oh, come on. Maybe you guys can see it a little bit better now that I've ripped off some of the plastic. Now that didn't do much. Even with my readers on, it's kind of hard. There you go. You guys see that all okay?
Mm-hmm.
So you can kind of see there's like 2 pins on the bottom and 1 pin on the top. So that's an example of a transistor. And then right here is an example of a 555 timer. We're going to solder that tonight. And then I'm going to use the reflow plate to put this guy on. And this is a 16-pin chip. Turn it sideways so you can see it a little bit better. So what we're going to do first is let me put this plate back here. And clear out the space here so we can actually do our work. And grab my 006 off. Okay. So the first thing we're going to want to do is we're going to want to tin one of the pads. So what I'm going to do is I'm going to lay my here and I'm going to just apply a little bit of solder. We don't need a whole lot. Just need enough to tin the pad. Next, I'm going to pull out a transistor, or I mean a resistor here. I'm going to grab it. This is where I actually need to use my trying to do is flip it over so it's right side up. Okay, so what I'm going to do is I'm going to set this down here so you guys can see it. I'm going to set it right there. And we're going to go back. I can steady my hand enough. And we're going to make sure that that solder bridges and comes up the side of it. Now what we're going to do is we're going to flip it around. And let me reposition this so you can see it. And we're going to apply solder to the other pin, or the other side. So soldering iron there. And now we got a little bit of extra there. Try to take some of that off. What we're looking for, it's kind of hard to see because we've got two big blobs there, is we actually do want it to kind of come up the side and down it. So let me see if I can take some of this away. That doesn't look like that's going to work. So we'll use some solder wick. And all I'm trying to do is just pull up some of the solder off the edge to make sure we got a good edge, a good connection.
Put a little flux on it, it'll wick better.
Yeah. Let me get some flux here. Oh, there we go. There we go. We got plenty there. Now let's try it again. The only bad thing about this microscope
I don't think there's anything bad about the microscope. This is unbelievable.
well, it's there we go. Now we pulled off that excess. You can see now that it kind of slopes up on the sides. It's not like a big blob. Now the next thing what we would do to clean that up is we'll take another cotton swab and we'll take some isopropyl alcohol. We're going to clean that up. Get rid of that excess rosin off of it. Okay. So now let's try to do this other one. We're going to do this 555 timer now. Let me position it here. So we're going to do the same thing. We're going to tin one of the pads. It doesn't matter which one we tin. And I'm actually going to put some rosin on this so that that'll help make the stuff flow a little bit easier. So let me put some rosin on it. I'm going to pull out my chip.
How large is the entire practice board?
It's probably about a 3x4 board, and it's got like 85 components on it. So it's designed so that you can really get good at it, you know, because the only way you get good is by repetition, right? Okay, so let me make sure I get this pointed the right way. Let's see here. Get it backwards. Let's turn it around. Now what I'm going to do is I'm going to press down on this. I'm going to bring over my soldering iron. Try to hold this in place. Let me get it set up again. Okay. Okay, so we've got that pin set. We got solder applied to it. So what we're going to do is we're going to rotate it around and we're going to do the opposite end. So we're going to do this pin right here. Let me get some solder. And we're just going to go ahead and do the next one. And you'll just see that I just bridged a, so we've got a piece here that I just bridged. So let's see if we can get that off. Choose our solder wick and we'll clean it up. There we go. We've got that side cleaned up. Now let's go around and finish the other side. It just takes patience and steady hands. And if you have a little excess solder on your soldering iron, you can sometimes just go right to the next one without using any more. And again, what you want to see is basically a nice smooth edge from going off the pin to the pad. If you got any bridges, you just use your soldering wick. Okay, let's clean that up and let's see how it looks.
Looks like the pulling movement that Roger taught me last time.
Yeah. Just slowly pull it off of it.
Got to clean your solder off your iron before you do it, though, because it's got to have somewhere to go.
Yeah. And that's what I have. What I'm using is one of those little, it looks like a little Brillo pad. The little brass Brillo pads that I put it in. And you want to try to make sure you keep your tip as, you know, no, you don't want any junk on it. If I can hold it down. Okay. So we could look at trying to pull a little bit off of here. Let's see if we can't get a little bit off of there. Yep. Let me turn it around so I can get to it better. Alrighty. So that's how to hand solder one. Now we're going to now take and do something a little bit different. We're gonna use the reflow board now. Let me zoom this back up. what I've put underneath there is a piece of plastic, and I'm going to squirt some, if I can get this to flow. Let's see here. Okay, so this is solder paste here. I'll put a little bit here. And it looks like we've got a pretty decent mixture there. You can, if you need to, you can actually take a syringe and add a little bit of flux, but this actually should have flux in it as well. It says no clean, so what we're going to do is I'm going to take, and I'm going to use a, let me get a little pin here. Oh, here they are. Oh, actually, here. This will work. I'm going to mix that up a little bit. And then what I'm going to do is I'm going to apply that right across here. This is similar to if we had a, what do you want to call it? A stencil. We'd put it down. I just want to make sure you got enough on each of the pads. Let me do this other side now. And what I'm just making sure is we got plenty on there on the pads so that when we heat this, it's going to solder that chip in place. You just don't want to have way too much on it, but you do want to have enough that the solder will melt and hold the pins. Okay, now let me get the other chip out. I'll put this guy in place.
What does this become when you fully populate it? Some kind of LED show thing or something?
Yeah, it's just some simple. It just basically creates a light of LEDs. Everything on the outside, all the the resistors and the capacitors, those don't actually have a function at all. It's just the centerpiece in the middle that does. Okay, let me grab this guy. If I can get it off. Yeah, that's the other thing, is that these tapes were meant to be used by machines, not by humans. So it's kind of hard to get those out sometimes. So let's see here. I got my pin there. Make sure I got enough room. Now I'm going to set that right there. Yeah, Jim, just move it. Okay, so now I've got that in position. So I'm going to switch over here to my overhead. And I'm going to set this board over here. So hopefully I can do this without knocking that chip around. And let me see about zooming in a little bit more. Because I don't know if you can see it, but what's going to happen is that's going to slowly melt the solder. And then what it should do is it'll get to a point where it will actually melt it all. That's it. Yeah, now let me just kind of out of focus though. You can't really tell. And it actually.
Can you focus a bit, Jim?
Well, I thought it was focused, but it's like this. Let's see if I can't drop another light down here. Maybe that'll help. That's out. It's way out of focus, isn't it? All right, let me just go back to full screen. Maybe that. I don't know if you can see it, but it's actually done. It just melts it, and then it. So let me pull it off here, and I will show you underneath the.
It actually melted that fast.
Well, no, it's still. If you notice, it's still got some way to go. So we'll put it back up there, but it has started melting it. So let me put it back up there. And
what kind of temperatures does that come up to?
right now, I've got it set at 145.
Okay.
I may increase the set temperature to about 150. Trying to. There's a little bit more light there, but it's like.
Well, for the uninitiated, I would think that if you put heat too long or too high, it would melt all over the place. So how do you adjust this properly?
Well, the rosin core is gonna. What's gonna happen is there's actually a thermo reaction between the solder and the copper, to where the solder will flow to the copper and actually create a molecular bond with it. And so because of the solder mask that's on it, the blue that you see around it, that tends to keep it from running all over the place. But if you put too much on it, you'll actually get bridges. And then you'll have to go in by hand with the solder wick to remove those bridges. But it just takes a little while for this to actually melt. We'll just keep an eye on it. There is some smoke coming off of it. I don't think you guys can see that. You get my binocular specs out so I can actually see what's going on with it. It's getting closer. From what I can tell, it looks like it may be done. That's the other thing. If you have a set of jeweler's visor where it's got the high magnifying lenses on it, that helps as well. Let's see. We'll take another look under the microscope and see. They still could do a little bit more. We'll put it back underneath there. Okay. We'll just give it a little while longer. What did I do with my phone? Okay, the National Weather Service alert just went off in the other room. Let's see what my radar says.
Bill just got the first wind gusts, and I'm watching the
Okay.
radar. So it's inbound. Whether each house gets water is who knows, but
It looks
the
like it's
front
still
is.
well north of Denton.
I think so, but what we're getting is a gust front.
Yeah.
Yeah, I gotta disconnect this stuff here.
Yeah, if you got radios connected, it's probably a good thing to pull them. We'll just let this go a little bit longer. And then I'll pull it. And if we have to, we'll just touch it with the soldering iron. Now, as far as this weekend goes, I got a message from DHL that they're supposed to deliver our boards on Friday. So let me switch back over here to microscope. You can see it hasn't melted everything. Probably would need to bring it up a little bit more, but let me put some rosin on it, and then we'll just hit it with the iron. We'll run the iron down it. But if you have a stencil and like a reflow plate like this, it makes putting your chips on and stuff so much easier. Okay, what I'm going to do is I'm just going to run the soldering iron along it, clean it up. Make sure we get all of it.
So the iron itself will pull rather than using the solder reflux or the solder pull, correct?
Right, correct. It'll pull any excess off, and it should even it out. It'll also melt all the remaining solder paste that we have on here, which is what I'm trying to do to make sure we have a good connection.
Okay. Is what we're seeing a problem for circuits crossing?
No, I don't think it is. As a matter of fact, I'm going to clean it up here and see if we can't get some of the this other off of here. You're thinking about shorts, right? Across them, like if we had a bridge.
Exactly.
Yeah, I don't think that'll be a problem with this. I would tend to want to do it more. What do you want to say? Be a little bit more. I would probably run it up hotter, just to make sure that everything did melt.
I think he's talking about all the little solder balls. If you take a little toothbrush and get a little rougher with it, I think it'll clean those up.
Yeah.
The toothpaste with some alcohol should clean those solder balls up.
Yeah. Well, that's
Because it
what I'm
looks
doing
like a
right
couple
now.
of them might bridge there on pin 1 or so.
Alcohol actually removes it.
Well, it just helps lift it up and get it out.
Yeah,
Um,
it's a solvent to the rosin and the stuff in the paste, and it'll loosen it up. Those little solder balls are not attached to anything. The solder mask is keeping them from being attached. See, they're moving with the alcohol there.
And my problem is I don't know the questions to ask, so it's
Oh,
all
you're
new.
asking the right questions though, because that would have been one of my first things. Well, you got all that leftover solder paste. Isn't that going to cause a connection problem or something? And that's where you would clean it up like we're doing now.
Hmm.
Now, we could also take a paper towel and hit it as well. For what we're going to be doing, which is going to be more of stuff this size, it's going to, we can actually, if it's going to be a lot easier for us to work with it compared to like these little pins. I've got a couple here that I did by hand. This is one of the first ones I did by hand, and I'm like, forget that, because it just was a pain. And I think I've got another one here. These are all different chips. Like, see, you can see where I pulled. There's still a little blob of solder on it. But this is one of those where I basically put too much solder paste on it, and then basically had bridges, and so I basically had to clear those bridges out. So I think that's it. So
Jim,
I wanted to give you guys, yeah.
So if you make your paste a little thicker, I think your paste was a little thin. If you make it a little thicker and you set the part on there, if you kind of start up high with your gun and kind of get it started to flow and then move your gun down, the surface tension of the solder will hold the part in place and it'll actually align it with the pads. So if you don't just get jam the tip right down there of the airflow gun right on it right away, if you start up high and kind of work down to it, it'll just melt the paste and then pull it in place. So,
well, that's good. A good tip.
You need a little thicker paste than what you use today, I think, to be
Yeah.
successful with the air gun.
When you say a little thicker paste, Roger, is that something you buy? You buy it like you buy viscosity oil?
No. Did you notice looking at his was real liquid, and you could see the little solder balls floating around there. His had too much solvent mixed in with it. Did that came straight out of the tube, or did you mix that up, Jim?
That came straight out of the tube.
Yeah.
And I think that's because this is a low temp solder paste compared to, I've got some other stuff that is thicker that is a regular temperature.
Mm-hmm.
But it's kind of old. But I'll bring
you
some
can take you can take solder paste in a jar and just mix it with the rosin to get any consistency you want, and it works a lot better if it's a little thicker than that. It'll actually draw into the pad. That was probably a little thin.
No, I agree. It was a little thin. So the first set of resources I wanted to give you guys were just if you wanted to practice and play with it, were 3 different. Apparently, Geek Fun are the only ones that sell these. I think if you were to go to Adafruit or to trying to think of who's the other one that does hobby electronics, you can actually get other soldering practice kits. But
yeah, I have the same microscope that you do, Jim. I'll bring it with me this weekend too, because I can't do that without a microscope. It's just
I
too
can't
small.
either. Even with my my visor with the double magnification, I
Right.
cannot do it. You have, and doing it under the microscope takes a little bit of getting used to looking at the screen and moving your hands.
Right.
Um,
Well,
so it's a
we can
little bit
actually
harder.
we actually can connect the microscope to the big screen too, so everybody can see what's going on when you're doing it. So
Yeah.
I'll
Well,
bring
and
my
I've got
cords and
a
stuff.
yeah. I'll bring my my capture thing so that then we can play it through my TV and or through my computer and up. Oh wait, no, I have a regular HDMI. I'll just have to find a because it's got a micro HDMI port on it.
Yeah, I've got one. I'll bring it.
Okay. This is one, and again, it doesn't really make anything big. It does have like a measurement thing, so you can get an idea of what the different sizes are um, of the different packages. Here's another one um, that I bought, and see, this has got a bunch of like 36 QFP 44 pin packages, as well as some 16 pin packages, but they don't really do anything. It's just for you to have something to practice soldering with and get used to it. And then here's another one that this actually has a whole bunch of LEDs on it. And plus you've got a couple of chips over here that you can solder, you get practice soldering. I myself, like I said, I prefer to have a stencil and lay down the paste and then place my components and then and then put it on the hot plate. And this I'll push up a PDF of this presentation so you guys will have these links. There's also some really good YouTube stuff. I know Roger, you sent us a link last week. Mr. Solder Fix has a lot of SMD tutorials. He covers how to do not only like resistors, capacitors, and the chips, but he also shows how to solder on electrolytic capacitors, switches that are surface mount and stuff. He's got like a 4-part tutorial out there. And then Electro Noobs, they've got a very basic SMD soldering tutorial as well. And you'll once you go out there and looking for, if you just go to you go to YouTube and you just type in SMD soldering tutorial, you'll find 100 different tutorials. But those were two that I thought would be of use to you if you want to learn more and go back and refer to it. They're going to go into more detail than I did. But at least they'll give you a head start of what you can expect.
Bill has a question.
Go ahead, Bill.
On the board, the initial board you showed for a practice was actually powered. If you make a mistake, which I obviously will as a neophyte, and bridge some of those components, am I going to short out the whole box or everything I do?
No, if you had, let's say that you had 2 pins bridged, it depends on what pins it is. If it was like the power and the ground, you'll probably burn out that component. If it was like maybe 2 signal pins, then you wouldn't even know you had bridged them, unless you did your inspection. And you may get your signal might be a little bit weird. It may not be what you're expecting. So, because a lot of the pins, like on that, well, here, let me switch back over to the 555 timer, and switch over here to the microscope. So there's one pin for ground, there's one pin for voltage, and then 2 ground pins, and then there's usually a couple of input pins and then output pins. So if maybe you bridged an input and an output pin, you might have an issue. Or if you were to bridge the voltage to an output pin or something, or to the ground, But again, you just got to be, you got to take your time and inspect it, and look at it and make sure that before you apply power to it, that you've addressed any bridges that you might have. And really, to tell you the truth, if you use a little amount, like I did there, where I just kind of tacked it and then did one side and then the other, and then just use a little bit of amount of solder. It's yeah, you can bridge it, but that's because I blobbed up some solder. But if you're careful with it and use your solder sparingly, it'll make it kind of hard to bridge. And again, is to flux. In this case here, the Rosin Flux is your friend, because it's going to try to keep it to where it's going to the metal nearest to it, not across pins.
Thank you.
As I say, anybody else have any other questions?